Let's consider some difficult problems to do with surds. Firstly, we're asked to simplify this really nasty looking expression. Let's see if we can break it down into expressions that are easier to deal with. So the 5 root 3 squared bit I will call A, the 2 root 18 over root 2 bit I'll call B, and then the root 32 root 2 bit I'll call C. Let's see if this makes it easier. I know that 5 root 3 squared is 5 root 3 times 5 root 3, which is the same as 25 times root 3, which is 3, which gives me 75. I know that 2 root 18 over root 2 I can simplify into 2 root 18 over 2, which is 2 times root 9, which is 2 times 3, which is 6. C is root 32 times root 2, which I know is root 64, because I can say that it's root 32 times 2, which is just 8. So in fact, my expression is really just 75 take away 6 over 8, which gives me 69/8. And if I wanted to simplify that, I could say 8 into 64 goes 8 times, with remainder of 5, giving me a final answer of 8 5/8. Here is a very similar question for you to try. Just have a go at it. It might be a bit tricky. Have a go at it, and when you're ready for the answer, press play. Okay, let's go through the answer. 2 root 3 all squared should be 4 times 3, which is going to be 12. 2 root 32 over root 2 is 2 root 16, which is going to be 8. On the bottom, 3 12s are 36, so I have root 36, which is going to give me a final answer of 4 over root 36, which is 4 over 6, which can be simplified to 2 thirds. The reason we actually work with surds is because we can use them to estimate more difficult surds. So, for example, given that root 2 is approximately 1.4, which you can very easily see with a calculator, we can use that fact to estimate more difficult surds without needing a calculator. So, for example, root 8, let's see if we can simplify that to get it in terms of root 2. I know 8 is equal to 4 times 2, so I've got root 4 times 2, which is just root 4 root 2, which is 2 root 2. So I can say root 8 is 2 times root 2, but given that root 2 is approximately 1.4, this is just 2 times 1.4, which is 2.8. Root 18 is root 2 times 9, which is just going to be 3 root 2. And again, given that root 2 is approximately 1.4, I can say that this is approximately 3 times 1.4, which is just going to be 4.2. And we can see this isn't actually a bad estimate, because if I try root 18 on my calculator, I do get to one decimal place 4.2, so it's quite a good estimate. Here is a similar question for you to try. Given that root 3 is approximately 1.7, estimate to 1 dp. Pause the video now and have a go, and when you're ready for the answers, press play. Here are the answers. Let's consider some harder problems again by looking at trigonometry with surds. For example, triangle ABC is a right-angled triangle with AB equal to 2 centimeters, BC equal to 6 centimeters, and AC equal to x centimeters as shown. We want to find x, simplifying our answer as far as possible. In the question, we're given a right-angled triangle with 2 known sides, and we want to find the third side. So we should know that we need to now use Pythagoras' theorem. And Pythagoras states that the sum of the squares of the 2 smaller sides, so in this case, AB squared plus BC squared, is going to be the square of the hypotenuse, or the longest side, AC squared. I can now substitute the numbers in. AB squared is 2 squared, which is 4. BC squared is 6 squared, which is 36. And AC squared is just x squared. So this means that x squared is equal to 40. To get x on its own, we need to do the opposite of square, which is square root. So x is the square root of 40, which is going to be, if I want to simplify this, I can say root 4 times 10, which just gives me root 4 root 10, which is 2 root 10 as my final answer. In question B, we're now given an angle, so that means if we have a right angle triangle and angles involved, we need to use trigonometry, basic trigonometry. So we have a right angle triangle, PR is root 27, PQ is y, and PRQ, the angle is 60 degrees, and I want to find y. So we need to use SOHCAHTOA, so basic trigonometry. We label the triangle as we've done in previous videos. So I have opposite the right angle, that's my hypotenuse. Opposite the angle that we're given, that is the opposite. And the remaining side would be the adjacent, which we don't actually have. So we want the opposite, and we have the hypotenuse. So I'm going to tick off opposite and hypotenuse in my SOHCAHTOA formulae. I can see that the sine formula has been ticked twice, so that's the one that I'm going to use. We want to find y, so I'm going to write down sine of 60 degrees is equal to the opposite over the hypotenuse. So I can say sine of 60 degrees is equal to the opposite, which is y, over the hypotenuse, which is root 27. Now, sine of 60 is equal to the square root of 3 divided by 2. Just to show that to you if you're not sure, sine 60 is root 3 over 2. So I can say root 3 over 2 is equal to y over root 27. To get y on its own, I multiply both sides by root 27. So I have y is equal to root 3 over 2 times root 27, which is the same as root 27 over 1. So I have y is equal to root 3 times root 27, which I know is root 9 times root 3, all over 2. So I have y is equal to root 3, which is just 3, times root 9, which is 3, over 2, which just gives me 9 over 2, which is 4.5 centimeters. Here are some really difficult questions for you to have a go at. So just try them, pause the video to have a go, and when you're ready for the answers, we'll go through them. Press play. Okay, let's go through the answers. So in the first question, we have again a right angle triangle. We only know the value of the right angle, so we're going to use Pythagoras. We want to work out xz, simplify fully. So I'm going to say that yx squared plus yz squared is equal to xz squared. That's just Pythagoras' theorem. 3 squared is 9. 3 squared is 9. So I can say xz squared is equal to 9 plus 9, which is 18. So xz is going to be the square root of 18, which is the square root of 9 times 2. So xz is equal to 3 root 2. Now xz is equal to 3 root 2, and given that root 2 is approximately 1.4, I can therefore say that xz is approximately 3 times 1.4, which is 4.2 centimeters. For question 2, I want to find the length of the diagonal of the square. Well, I know that the interior angle of a square is going to be 90 degrees. So I can just consider the right angle triangle formed on the left side here. So I have the two smaller sides are both 4. The longer side I could call C. I state Pythagoras' theorem, a squared plus b squared. The two smaller sides squared and added up is the longest side. So I have c squared is equal to 4 squared, which is 16, plus 16. C squared is equal to 32. To get c on its own, we square root. So I've got the square root of 32 for c, which is just root 16 times 2, which works out to be 4 root 2. Finally, find the length of one of the sides of the square shown below. Well, I know the square has all of the sides equal, so if I call each of the sides of the square a, I can again use Pythagoras' theorem because I have a right angle. The two smaller sides, a and a, will add up to, well, a squared plus a squared will be root 50 squared. So on the left hand side I have 2a squared. On the right hand side I've got root 50 times root 50, which is 50. I can now divide both sides by 2 to get a squared is equal to 25. And to get a on its own, I'm going to square root both sides, which gives me a is equal to the square root of 25, which is 5 as my final answer.